Okay, so let's look at the example we have in our note sheets here. We have the situation where you have these car companies testing the miles per gallon for one of their car models. Random sample is taken, and then we have the miles per gallon after 100 miles were recorded. Okay, and so here are the values. And again, why statistics is powerful is that you have all this data, this kind of raw data, that somehow we have these tests to somewhat consolidate these ideas. Because just by looking at it, we may say, you know what, they're the same, they're different, we're not sure. And so let's go ahead and test to see if there's sufficient evidence to show there's a difference in at least one of the car models. And so looking at, and we use the alpha 0.10 rating to do that, our level significance. Remember, we have all our hypothesis tests have similar setups, right? You have your null and alternative, right? That the means are all the same. And that is always what we're looking at here, okay? That will always be our null hypothesis. And then at least one. So pretty much this is the same for all tests we do, okay? For all ANOVA tests, okay? It's just the context that changes. And then you have, what is this, a one ANOVA F test? In this case, again, we're going to assume the conditions are met. Again, sometimes it's not easy to verify all of those. And again, in the real life, you would have to, if you were really doing statistics and doing a full study, you would have to make sure that those requirements are met. And if not, then you'd have to come up with some ways to interpret it, or different ways, right? Or be careful with the results. And so let's just assume they're all met in this case. And then we need to calculate these. Where do those come from? That's going to come again from your ANOVA table. So I want to make sure you're aware of that again, and that will come from technology, as we showed on the last example. So let's go just double check and verify again how you get that, get those values. So let's look at StatCrunch. I have the company values in already. And then from there, you're going to stat ANOVA one way. And then I want company 1, 2, and 3. Dot plots are good so you get the visual of it. And that would be it. And then you can see you get your p-value, your F statistic. And then you can see the distribution, right? And they look pretty similar. Again, it looks like, again, here, there's a chance they may not be different in terms of, and this grand mean is, again, the mean for all the groups together. And so looking at that there, we can then go ahead, I'll go back to the table. There it is, a p-value and test statistic. That would then lead us to a conclusion. Since the p-value is just a little bigger, we're going to fail to reject this. So that means that we're accepting that, and we're accepting that and saying that's not true. And so now we say there's insufficient evidence to show a difference in mean miles per gallon between the car companies. There's not enough evidence to suggest that the difference. So we're going to settle on that maybe the means are the same, that there's no difference between the groups.